Welcome to our math lesson today. We're going to solve a problem that asks us to find the largest integer value of k that allows a quadratic equation to have two distinct real roots. The equation we're given is kx squared minus 29x squared minus 18x plus 9 equals 0. Before we dive into the solution, let's first understand what determines whether a quadratic equation has two distinct real roots. For a quadratic equation in the standard form ax squared plus bx plus c equals 0, the discriminant b squared minus 4, ac tells us about the nature of the roots. If the discriminant is greater than 0, we have two distinct real roots. If the discriminant is equal to 0, we have exactly one real root, a repeated root. And if the discriminant is less than 0, we have no real roots, two complex conjugate roots. Let's go back to our original equation, kx squared minus 29x squared minus 18x plus 9 equals 0. First, I notice there's a slight issue with the equation as written. We have two x squared terms with different coefficients. Let's combine them to get the equation in standard form. Combining like terms, we get k minus 29, x squared minus 18x plus 9 equals 0. Now, we can identify the coefficients in our standard form equation. A equals k minus 29, b equals negative 18, and c equals 9. We want to find the largest integer value of k, such that the equation has two distinct real roots. This means we need the discriminant to be strictly greater than 0. b squared minus 4, ac is greater than 0. Let's substitute our values. We have negative 18 squared minus 4 times k minus 29 times 9 is greater than 0. Let's simplify this expression step by step. First, negative 18 squared equals 324. Next, for times 9 is 36. So our inequality becomes 324 minus 36 times k minus 29 is greater than 0. Simplifying further, we get 324 minus 36k plus 36 times 29 is greater than 0. 36 times 29 equals 1044. So we have 324 plus 1044 minus 36k is greater than 0. Adding 324 and 1044, we get 1368 minus 36k is greater than 0. Now let's solve this inequality for k. We have 1368 minus 36k is greater than 0. Subtracting 1368 from both sides, we get negative 36k is greater than negative 1368. Dividing both sides by negative 36, and remembering to flip the inequality sign when dividing by a negative number, we get k is less than 38. Let's visualize this solution on a number line to better understand what we're looking for. So, k needs to be less than 38 for the equation to have two distinct real roots. But the problem asks for the largest integer value of k. Since k must be strictly less than 38, the largest integer value for k would be 37. Therefore, the answer is k equals 37. Let's check our answer by examining the graph of the quadratic function. With k equals 37, we should see that it crosses the x-axis at two distinct points, confirming that it has two distinct real roots. Let's also verify what happens if we try k equals 38. With k equals 38, the equation becomes 9x squared minus 18x plus 9 equals 0. This can be factored as 9 times x squared minus 2x plus 1 equals 0, which is 9 times x minus 1 squared equals 0. This gives us a repeated root at x equals 1, showing that with k equals 38, the equation has exactly one real root instead of two distinct roots. This confirms that 37 is indeed the largest integer value of k that gives us two distinct real roots. To summarize, we found that for the equation kx squared minus 29x squared minus 18x plus 9 equals 0 to have two distinct real roots, the discriminant must be positive, which led to the condition k is less than 38. Therefore, the largest integer value of k that satisfies this condition is 37.